Hello everyone, welcome to the lecture again. In the last lecture, we discussed about the translation and rotation of rigid bodies. We saw that the general plane motion can be considered as the combination of the translation and rotation about a fixed point. We also discussed about the relative velocity. Today, we will discuss few examples of the relative velocity and also discuss the relative acceleration. So, let me write down the first problem statement. It is following. The pinion A of the hoist motor drives gear B, which is attached to the hoisting drum. The load L is lifted from its rest position and acquires an upward velocity of 2 meter per second in a vertical rise of 0.8 meter with constant acceleration. As the load passes this position, compute A, the acceleration of point C on the cable in contact with the drum, and B, the angular velocity and angular acceleration of the pinion A. Okay. So, first of all, it is given the load L moves in the upward direction with a velocity of 2 meter per second in a vertical rise of 0.8 meter. From here we can find out what is the velocity of the load at that instant. Okay. So, let us do that. We know that V square equal to U square plus 2 AS. Now, V is given, it is 4 equal to 0 plus 2 into A into S. S is 0.8 meter and from here we get the acceleration. Okay. So, this is the acceleration, it comes out to be 2.8 meter per second square. This is the acceleration of the load. Now, this load is connected by a cable, therefore, the acceleration of the cable or rather the tangential acceleration of the cable will be 2.5 meter per second square. Okay. So, this is the tangential acceleration at point C. Okay. And the same is true for the velocity also. The tangential velocity at C will be 2 meter per second. Okay. So, let me write down the tangential velocity, let me call it V because there is no radial velocity, okay, will be 2 meter per second, okay, and the tangential acceleration at point C will be 2.5 meter per second square. Now, from this velocity I can find out what is the normal acceleration. Okay. Now, note that the normal acceleration a n, okay, still at point C, will be v square divided by r. Now, v is given, it is 2. So, therefore, this will be 2 square divided by r. R is the radius of the gear. It is given that the diameter is 0.8 meter. Okay. So, this is the diameter, therefore, the radius will be 0.4 and that comes out to be 10 meter per second square. Therefore, the acceleration of point C will be square root a t square plus a n square, and a t and a n is known to us. So, that comes out to be 10.31 meter per second square. Now, in part B, we have been asked to find out the angular velocity and angular acceleration of the pinion A. Note that the pinion A is connected inside the gear. Okay. So, therefore, to find out the velocity and acceleration, first we have to study what is happening at point B, which is inside the gear. Okay. So, note that the omega, the angular velocity and the angular acceleration alpha will be the same for both point B and point C. Okay. So, therefore, the omega B or the omega C will be V divided by R. Now, the velocity at point C is known, it is 2, and the radius at C is 0.4. So, that comes out to be 5 radian per second. Similarly, the angular velocity at point B or C will be a t divided by r. Now, at point B it is 2.5 divided by r is 0.4. So, therefore, it comes out to be 6.25 radian per second square. Now, note that the gear B drives the pinion A, therefore, the tangential velocity and the acceleration will be the same. So, velocity v equal to r a omega a equal to r b omega b, and the acceleration r a alpha a equal to r b alpha b. Okay. So, therefore, the omega a will be r b over r a into omega b, and omega b is known, r b and r a is also given in the figure. So, that comes out to be 0.3 divided by 0.1 into omega b is 5. So, that is equal to 15 radian per second. Okay. Now, alpha a will be r b divided by r a into alpha b. Okay. Now, r b and r a is known, alpha b will be equal to alpha c or alpha b. So, that is 6.25. So, this comes out to be 0.3 divided by 0.1 into 6.25, and that is equal to 18.75 radian per second square. Now, let us look at another problem statement. The common configuration of a reciprocating engine is that of the slender crank mechanism shown. If the crank OB has a clockwise rotation speed of 1500 revolution per minute, determine for the position where theta equal to 60 degree, the velocity of the piston A the velocity of point G on the connecting rod and the angular velocity of the connecting rod. Okay. So, in this question we have been asked to find out what is VA and what is VG. Okay. So, first of all we have to note that the point O here is fixed and therefore, point B is making a fixed axis rotation. Okay. So, if it is making a fixed axis rotation, that at any instant the velocity of point B will be perpendicular to OB. Okay. So, therefore, this angle has to be 90 degree. Okay. Let me write this down. Point O is fixed, therefore, B will make a fixed axis rotation. Okay. And therefore, the velocity of point B will be perpendicular to OB. Now, if an observer is fixed at point B, then he will see as if point A is making a fixed axis rotation. So, from the prospect of B, point A is making a fixed axis rotation, therefore, the angle of VA with respect to B will be perpendicular to the connecting rod AB. Now, let us look at the velocity of point A. Velocity of point A therefore, will be the velocity of B plus VAB. Similarly, the velocity of point G will be the velocity of B plus VGB. Okay. Let me call this equation number 1 and this as equation number 2. Velocity of B can be very easily find out, V equal to R omega. So, therefore, velocity of point B will be R, which is 0.125 into omega. Omega is 1500 revolution multiplied by 2 pi divided by 60 and that comes out to be 19.63 meter per second. Okay. And as I said, the direction of VB will be perpendicular to OB. Okay. Now, what is the direction of A? The direction of A, okay, or let me call it VA, is along the horizontal, okay, because this piston A is moving in the horizontal direction and the direction of VAB. So, this is again I said that the direction of VAB is perpendicular to the line AB, okay, and this is because of the relative motion. This is how point B will perceive point A. Okay. Now, let us look at the triangle ABO. So, we have the velocity of A, okay, and we have this point O, and then we have point B. It is given that this length is 350 mm, this angle is 60 degree, okay, and the R is 125 mm. Note that the velocity will be perpendicular to OB. So, this is the velocity of B. Now, from here I can find out what is this angle beta, okay, this angle beta. So, for that I can use the sine law, which is 125 divided by sine beta equal to 350 divided by sine 60 degree, and from here I get beta equal to 18 degree. Okay. So, this beta comes out to be 18 degree. Now, since one of the velocity VB is known and also we know the angle beta, let us look at the velocity triangle to find out what is VA and what is VAB. Okay. So, we are looking at the velocity triangle. Okay. So, some of the geometry is involved. So, we have the velocity of point A in the horizontal direction. AB rod is making an angle of 18 degree. So, this is something that we find out, and VAB is perpendicular to AB. So, therefore, that angle will be 72 degree. Okay. So, we have VA, VAB, now we have VB. Okay. Now, note that this VB is making an angle of 90 degree with respect to OB. Okay. And this angle is given, it is 60 degree. So, if this angle is 60 degree, therefore, that angle will be 60 degree, and therefore, this angle will be 30 degree, and since this is also VB, that is also VB. So, they are supposed to be parallel, therefore, this angle will also be 30 degree, and so is this angle. And from the triangle, total sum should be 180 degree, therefore, this comes out to be 78 degree. Okay. Now, we can use the sine rule to find out all the velocities. So, we have VA divided by sine 78 degree equal to VB divided by sine 72 degree. Okay. And the velocity of B is known, this is equal to 19.63, something that we have find out. So, from here very easily we get VA equal to 20.2 meter per second. Okay. Now, we can also use VAB divided by sine 30 degree equal to 19.63 divided by sine 72 degree, and that gives me VAB equal to 10.32 meter per second. Therefore, we can find out what is omega AB, the angular velocity of A with respect to B. It will be VAB divided by the length AB. So, that will be 10.32 divided by AB is 350 mm. So, that is 0.35, comes out to be 29.5 radian per second. And note that since B is rotating in the clockwise direction, therefore, B will see as if A is rotating in the counterclockwise direction. Okay. So, this will be in the counter clockwise by the sense of B. So, this is how B will sense. We have been asked to find out what is Vg. So, velocity of G will be velocity of B plus velocity of G with respect to B. Now, this was our equation number 2, and Vgb will be Gb times omega AB, and Gb is 100 mm. So, 0.1 into omega just now we have calculated 29.5. So, that comes out to be 2.95 meter per second. So, now we know Vgb, we also know Vb. So, in principle we can calculate what is Vg, but note that this is a vector sum. So, you have to take care of the direction also. So, we have Vb which is equal to 19.63, and this makes a 30-degree angle from the horizontal, and we have Vgb. So, this is my Vb, we have Vgb, and that makes an angle of 72 degree from the horizontal. So, therefore, this angle will be 78 degree, okay. And from here I can find out what is Vg, okay. So, that will be square root this is square plus that is square plus 2 Vb, Vg and the angle between them. So, that gives you Vg equal to 19.24 meter per second. Now, let us understand the concept of relative acceleration. Okay. We saw that if a rigid body is making a general plane motion, then the motion can be analyzed as a combination of a translation and a fixed axis rotation about a point. So, let us say that point is B. So, it is the combination of the translation and the fixed axis rotation about B. And we also saw that the velocity of point A will be the velocity of point B plus velocity of A with respect to B. Now, if we differentiate it, then we get the acceleration of point A equal to the acceleration of point B plus the acceleration of point A with respect to B, and all of them are vector quantity. Okay. Now, note that this acceleration of point A with respect to B will have two component. It will have the normal component and the tangential component. So, A can be written as AB plus AB the normal component plus the tangential component. And what is the value of the normal component? An will be V square divided by R. So, VAB square divided by R, or you can also call it R omega square, and VABT will be R omega dot or R alpha. Okay. Let us look at the direction. So, let us say omega is like this, alpha is also like that, then ABN will be towards AB, and AABT will be perpendicular to AB. Okay. Now, based on this concept, let us look at a problem statement, and the previous question is repeated here. So, the crank OB has a constant clockwise angular speed of 1500 revolution per minute for the instant when the crank angle theta is equal to 60 degree. Determine the acceleration of the piston A and the angular acceleration of the connecting rod AB. Okay. So, we have been asked what is the acceleration of piston A and what is A with respect to B. Now, just now we saw that the acceleration of A will be the acceleration of B plus the acceleration of A with respect to B. So, that is ABN plus ABT, okay, and all of them are vector quantities. Here the crank OB has a constant clockwise rotation. So, since it is constant, therefore, omega dot will be 0, and therefore, AB T will be 0. Okay. So, there is no tangential acceleration of point B. So, therefore, point B is only under fixed axis rotation. Okay. So, we have AB only the n component, because this AB can also have AT and AN, but AT is 0. So, AB will be equal to AB only n, and that is equal to R omega square. Now, R is 0.125, omega is 1500 into 2 pi divided by 60 square, and that comes out to be 3080 meter per second square. Okay. So, therefore, AABN can be find out now. So, AABN will be R omega AB square, and R is 0.35, and omega AB we have calculated in the previous problem. So, omega AB was 29.5 radian per second. So, that will be 29.5 square, and this comes out to be 305 meter per second square. Okay. So, now we know ABN, and if we find out ABT, then we know what is AA and what is AAB. For that, let us look at the geometry of the acceleration. So, we have O here, A here, and we have B. Okay. The acceleration of A will be along AO. So, this is the direction of the acceleration. Point B is making a fixed axis rotation like that. So, therefore, the direction of ABN will be towards BO, and there is no ABT. To point B, point A is rotating in the anti-clockwise direction and the component of AABN will be along AB and AABT will be perpendicular to AB. Okay. And also note that we have already determined that this angle is 18 degree and this angle was given that it is 60 degree. So, now let us look at the acceleration polygon. Because we know some of the accelerations and the angle between them. So, we have the acceleration A which is in the horizontal direction, then at 60 degree we have AB N. So, this is 60 degree and this one is ABN. Its value we have find out, the value is 3080, okay, and at 18 degree we have ABN and its value also we have find out, it is 305, this is 18 degree, and then at 90 degree to it we have ABT. Okay. So, this is AABT, okay, and this angle will also be 18 degree from the geometry. So, now let us equate the horizontal and vertical component so that we can find out all the values. So, let me take this as positive direction and that as positive direction and I am equating the horizontal and vertical accelerations. Okay. So, AA will be equal to 3080 cos 60 degree plus 305 cos 18 degree minus AABT sin 18 degree and the vertical component is 0 equal to minus 3080 sin 60 degree plus 305 sin 18 degree plus AABT cos 18 degree. So, now we have two equations and there are two unknown. From here we can find out that AAB T equal to 2710 meter per second square and AA equal to 994 meter per second square. Okay. And the angular acceleration of AB, which is alpha AB, that will be AT divided by R, and AT is 2710, R is 0.35. So, that comes out to be 7740 radian per second square in the clockwise direction. Okay. With this, let me stop here. See you in the next class. Thank you.